Hi guys, another day, another topic. So day 5, we are going to answer questions with you from electrostatics. Question 1. I hope you did try already. You are going to get full mark. This question paper with 10 marks and then multiple choice questions with 2 marks. All right, let's see what they ask now. Two identical spheres R and S. All right, staying there. Spheres R. Okay, force is F. Okay, for electrostatic force between R and S is F. All right, so on sphere S, it means we can write, we can say F R S is F. Let's write here. You remember, if you have positive and negative charge, they attract each other. And then we can write here, so we have this side. We have this side. Let's write. Let's draw and show. This one is given. F R S. So, and then this one is, as you know, F S R. It means because of R on S, force is given. This is SR. So FRS equals F. It is given in question. Okay, let's see what they ask. Two spheres are now contact each other, all right, and they are coming to original position. Okay, so magnitude of electrostatic force, that sphere R. Okay, because spheres are on, it means of FRS. They are asking you how many F. We can say F over 2, F, 2F, or 0. Which one is correct? So they are touching each other and separating. Oh, you see already, if they touch each other, they are going to get 0 charge, right? What's our final charge? Final charge formula. Do you remember that? Final charge is equal to Q1 plus Q2. Q1 plus Q2 over 2. You know that? So we can say plus Q and minus Q over 2. And you are getting 0. If they have 0 charge, 0 coulombs, of course, they are going to make 0 force. That's it. So this is our answer. But if you get different charge, of course, you can compare with first one. But for now, we have 0 coulombs. Because of that, our answer is A. I hope it's clear. It was easy question, but we are answering with long process. It's fine. Just plus Q minus Q making 0, and then 0 charge making 0 force. That's it. Okay. And then next question. Let's see what they ask. Question 2. Two small charge spheres A and B. All right. And all charge given as you see. A with positive charge, B with negative charge. And the distance between A and B is given 0.4 meters. All units with coulombs. You remember, if you see another unit, please convert to coulomb. And if you see another unit for distance, we must convert to meters. And we have point M between A and B, midpoint. Yeah, that's important because otherwise we don't know between A and M. So A and M distance 0.2, M and B distance 0.2. Okay, now we know all givens, everything is sharp. So let's continue with state Coulomb's law in words. All right, Coulomb's law, last lesson was day 1, right? In day 1, they ask you electric field. Now, Coulomb's law. What is Coulomb's law? Let's see. Coulomb's law, magnitude of electrostatic force. Okay, just you can read all. Please just memorize all right. And this one is coming from this one is coming from electrostatic force between two charges. K is Coulomb's constant, you know, 9 times 10 to the power of 9. 9 times 10 to the power of 9, of course, with unit. You can just get unit because you will get this constant number. And then Q1 times Q2 over R squared. If you have two charges with Q1 and then Q2, distance between these two is R. So formula is K times Q1 times Q2 over R squared. This is our Coulomb's law. So what they said, magnitude of electrostatic force between charges is directly proportional to the product of the magnitude of the charges, product of charges, and inversely proportional to the square of distance. So from formula, you can get this one, this definition full coming from memorandum. So you can just memorize like this. If they ask you Coulomb's law, please write it down exactly the same. Otherwise, maybe you are going to lose your mark. Please be careful about that. So Coulomb's law, if you, yes, Coulomb's law, should we remove anything? Just try to memorize all, all definitions, very important. So last lesson, electric fields, now Coulomb's law. Let's continue with next question. Same circle, same diagram we are using, of course, AB. Now, question 2.2. Calculate the net electric field at point M. So, calculate net electrostatic force, calculate net electric field, Coulomb's law, Ohm's law, this kind of things, very important for electrostatics. So, how we are going to calculate net electric field at point M? First of all, we should get, maybe we can carry on. Yeah, let's show solution also here. So, first of all, on point M, what electric field we have? We should just draw with direction. That is very important. So, with direction, we are going to draw first. Okay, let's start with EA or E1, you can say, it's fine. So, you have positive, right? So, positive always repel to all objects. So, if you have positive charge, electric field direction this way, just repel, just remember that, all right? So electric field, this drawing is very bad. So electric field always repel. Okay, writing pad is making problem. So positive repel, just remember that. So A repel M. So if A repel M, direction of electric field for A, we can write EA this way to the right. Is it okay? And then what's next? For B, it is negative. Negative always attracts. Negative always attract all electrostatic force. So if it's attracting point M also. Okay, if it's attracting point M, so they have same direction. So maybe we can show like this. This is our EB. As you see, they have same direction, EA and EB, same direction. So we are going to calculate EA and calculate EB, and then we are adding them. That's it. So this is our solution. So let's calculate EA. This formula we know to calculate electric fields, K times Q. Electrostatic force, KQ1, Q2. But electric field only with one charge, KQ over R squared. R is distance between point M and A, and then, so what's our distance? 0.2 meters, right? Because they said midpoint, yes, so 0.2 meters. And K is equal to 9 times 10 to the power of 9, and Q for A is positive 2 times 10 to the power of 5, negative 5, yes, and when you calculate 0.2, of course, distance 0.2 square, and then when you calculate 4,5 times 10 to the power of 10 to the power of 6 Newton times Coulomb power of -1 Newtons per Coulomb, also we can say. Electric field at M because of B. Now we are looking for EB. Electric field B on electric field on M because of charge B. K times Q over R squared, this is our formula. And another formula, QB is equal to 2QA. Why? Oh, okay. Because this is just 2 times 10 to the power of -5. This is 4 times 10 to the power. As you see, it is double. If it is double, of course, electric field also double. It's another solution for you guys. As you see, another solution. If you use this way, also it's okay. So EB is equal to K times Q over R squared, and then 9 times 10 to the power of 9 for Coulomb's law. Coulomb's constant, sorry, for Coulomb's constant. And then Q is equal to 4 times 10 to the power of negative 5, 0,2 r squared. But you cannot use this one if you have different distance. Please remember that. Not always working. All right. Now 0.2 meters. This is also 0.2 meters. It's okay, but otherwise you cannot use this one. So this is best way. Yeah? So 9 times 10 to the power of 6 electric field. After that, we are adding them. EA plus EB, and you are just adding them and getting your electric field. And they didn't tell you magnitude of electric field. They said just calculate electric field, net electric field, as you see. Because of that, we have to give direction also. As you see, direction is another mark. To get full mark, please write direction. So question 2.2 also done. I hope everything is fine. How many marks we have done for now? 10 marks, right? I think we have done for today. Let's just double check. Another option here, but it's same stuff. So you are gonna see now directly just add. You know, Q. Oh, wait. Oh, calculating electrostatic force using long way. Anyway, just option they are giving in memorandum. Let's explain. So F net KQ1, Q2, you are calculating electrostatic force between them. When you get electrostatic force, F is equal to E times Q. We know that formula. And then you are just getting, but of course you should get charge also, charge for each, and then how we are getting that charge. So this is long way, people. And then you are using this option. Let me just double check how we are getting charge. No, just they cancel charge. Okay, F net is equal to E net times Q. So you're calculating F net first, and then writing E times Q, and then just Q charge cancel each other using this option. That's another way you can calculate. This is the long way. So because you're going to calculate electrostatic force between them, so it's fine. We don't need that. All right, so we have done for today. See you next lesson. You know what you are going to do. Please don't forget that. So we are going to carry on next lesson with electric circuits. Electric circuit, day 6. Day 6 next lesson. See you next lesson, everyone. Have a nice day.